Hi everyone, this is the fourth lesson on graphs and we're going to have a look at lines which are parallel to other lines, and we're going to have a look at lines which are perpendicular to other lines as well. So let's have a look at these graphs first of all. Okay, now the question at the bottom says find the gradients of each pair of parallel lines. What do you notice? Well, let's have a look at this red line first of all. You can see that if I pick this point down here and go across 1, I'm going to go up 1, 2, 3. So the gradient of this line here is 3. And if I pick, this point here on the red line, I go across 1, I'm going to go up 1, 2, 3 also. So we also get 3. Now if we have a look at the purple line, if I start from here, I go across 1, I'm only going up about a half, so the gradient's a half. And for the other purple line, if I start here, I go along 1, and I'm going to go up a half again, and so that's a half. So hopefully you've spotted the pattern here, that if two lines are parallel to each other, they have the same gradient. Okay? Now, these lines, however, are not parallel. So let's have a look at the red lines, first of all, and calculate their gradients. So the red line here, we're going to go across 1, we're going to go up 3, so that gradient is 3. And then the red line at the top, we can just about do it. We're going to go across 1, and I'm not going down a half there, I'm actually going down a third. So that gradient is minus a third. Purple line over here, I'm going to go across 1, I'm going to go up a half, so that has a gradient of a half. And then this one over here, let's start here, go across 1, and I go down 2. So look, you might be able to see a pattern here, you might not. But look, if one of them is 3, the other one is minus 1 over 3. And over here, if one is minus 2, the other one in here is minus 1 over 2. Strictly, the relationship between them is that if you multiply these gradients together, okay, then you get minus 1. So that's a test that we can do to see if two lines are perpendicular together. If they multiply together to give us minus 1, then those lines are perpendicular to each other. Oops. Okay, so let's have a look at some questions here. So, if the gradient is what? Now, what I tend to teach is, if one gradient is 2 and you want to find the gradient which is perpendicular to it, there's two things that I want you to remember. I want you to flip it, and then I want you to change its sign. Okay? So we'll start with 2 over here. If we flip it, we get a half, and if we change the sign, we get minus a half. Then we'll do minus 3. If we flip it, we get a third. And then if we change the sign, it becomes plus a third. A quarter, if we flip it, we get 4. And if we change the sign, we get minus 4. 5 becomes minus 1 over 5. Minus 2 over 7 becomes 7 over 2. And 7 over 5 becomes minus 5 over 7, okay? So if you can remember, flip it and change the sign for lines which are perpendicular, then you're probably not going to go far wrong. There we go. Okay, so hopefully if we've got that, we're going to go on to some problems. Is that easier? Yeah, they're fairly straightforward, these. Now, let's have a look at question 1. I'm going to complete it down here where I've got more room. A line goes through the point 9, 10 and is perpendicular to another line with that equation. What is the equation of the other line? Well, the gradient of this line is 3, and we want the gradient which is perpendicular to it. So I know that my gradient is minus 1 over 3. So we can start with y equals minus 1 over 3x plus something. Okay? Now, in order to work out that something, that y-intercept, I'm going to use this point up here. I know the line passes through 9, 10, and therefore 9, 10 must satisfy this equation. So the y-coordinate is 10, the x-coordinate is 9, okay? So 9 times minus a third gives me minus 3 plus c. So therefore you can see that c, how do I get from minus 3 to 10? I need to add on 13. So my equation here is y equals minus a third x plus 13. Okay? We're getting quite hard here, so you're going to have to use your brain a little bit. Now, number 2, a line goes through the points 1, 3 and 3 minus 1. Okay? So the first sensible thing to do is not read the rest of the question, but let's have a think. It's going to be to do with gradients. So let's calculate the gradient of AB, okay? So I'm going to do minus 1 minus 3 over 3 minus 1. So I've got minus 4 over 2. Now, so that gives me negative 2, okay? Now the rest of the question says a second line L2 is perpendicular to this one. Right, okay, so I've got y equals now perpendicular to minus 2. Remember, flip it, change the sign. So that gives me a half x plus something. Now a second line is perpendicular to L1 and it passes through B. So it passes through this point here. Okay? So let's find the equation of this line. Okay? So the x-coordinate is 3, the y-coordinate is minus 1. So I now have minus 1 equals a half times 3 plus something. Okay? So carry on over here because I've run out of room. Minus 1 equals 1.5 plus something. Okay? So how do I get from 1.5 to minus 1? I'm going to have to take off 2.5. Okay? So that's what my c is. It's going to be minus 2.5. So my y is going to be half x minus 2.5. But that's not actually the question. This is where we need to get good at really reading the questions. Where does L2 cross the x-axis? Now, if you remember what I said before, when lines cross the x-axis, we know that the y-coordinate is 0. Okay? So I'm actually going to solve 0 equals a half x minus 2.5. So in order to make my life a little bit easier there, I'm going to double everything. So 0 equals x minus 5. There we go. So you can see that x equals 5. But again, we've now got to do something else because actually where it crosses the x-axis is a coordinate. So we've got to state down that the coordinate is 5, 0. There's quite a lot in there and it's quite difficult, okay? I'm going to stop there. Perhaps you want to have a look at this again. But if we look at our question 3 down here, we're asked to see whether they are parallel, perpendicular, or neither. So all we have to do for each equation is work out the gradient and then look at them. So that has a gradient of a half. Now remember, in order to work out the gradient of this, you've got to get y on its own. Okay? So if I add y to both sides, I get y equals 2x plus 4. Now we know what the gradient is. The gradient is 2. Okay? and they're not the same, so they're not parallel. One of them isn't negative, so they're not perpendicular, so the answer is neither. Okay? And I think that's what I'm going to stop with there. So I'll see you on Saturday.